Oh, all right. Okay. So this becomes serious now. Yes. So what is the problem? What do you have to do now? How do you start? Yeah, okay. Yeah. 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 All right. Avoid the restrictions. Yeah. Have you used open form before? No. No. The first time. Right. Yeah. I think it's pretty useful actually because you can just get it for free as well. And but you don't do any simulation in your work now in your research in your own research? No. Yes. Yeah. No, that's all right. I'll just follow. So, so you probably know better than the others because you do simulations, don't you?
Yeah, but this is the fourth software on CFD I'm going to learn.
That's right. What do you use now?
I'm working on the console.
Right.
In
Okay.
my PhD, I use CFD-US.
Right.
And
Okay.
I learn answers.
Yes. Yeah. Yeah.
So,
Yeah. But people kind of move easily, I think, from ANSYS to open form.
yeah.
Yeah. Especially for somebody like you, I guess, that with some experience.
Conceptually, I know.
Yeah.
Thing is the command structure and other thing. That's the only thing I need to know.
Yeah.
Understand
Yeah.
what
Yeah.
is happening.
So you can find now quickly,
Yeah.
yeah, with some help. Yeah. Yeah.
Actually, I'm planning to move to open form
Okay.
because it's मतलब you know what is सारा समझ में आ गया.
Yeah.
So there are a lot of problems I'm facing. It's supposed the framework is not that easy than once.
Quite difficult, actually. Yeah. If you want to do beyond the, what type of problems do you want to do?
So right now I'm working on modeling of free-radical polymer system.
Yeah. Oh, yeah. Okay.
So it's a couple of table density, so still which transfer and
Okay. It's very challenging. Have you worked before with this flare problems or?
might be technical there.
Yeah. Okay. 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 Yeah.
So the problem is if everything is running, it's nice. But once you start, it's really difficult to figure out where from the figures. It's not that with the pending that way.
Mhm.
Changing different parameters without knowing what is happening.
What is your, yeah, yeah.
So
I mean, even the technical support, I mean, maybe we should be recorded on that, but you know, sometimes can be not so good.
it's been
Technical support from
technical support there, but it's like
if they have not done it themselves.
them every time. It's like sitting them with them all the time.
And also, if they have not done your problem, they may not
They are
know.
not there.
Uh,
So they are also and also expert in several things. So
Mhm,
it's like
mhm.
stuck the best we can do.
Yeah, yeah, and then sort it out yourself.
So ultimately, say, if you want to sort, it's better to work on this. At least you know what to do.
Yeah, yeah,
There you cannot touch anything.
yeah, yeah.
Okay,
Yeah.
it's like when we learn or teach CFD, it is basically FPM. This is all FPM. So the stone was the techniques that are being used. Yeah, very much.
Mm,
But those are techniques and formula around FPM.
yeah, yeah,
So their solvers are different.
yeah, yeah.
You don't know what choices to make. Those solvers like that.
No, no, no. You have to trust that, and yeah,
So you have to start from the program.
yeah.
Then I am
You teach safety as well. Yeah.
so I used to teach them for
Yeah.
right code in MATLAB.
Okay, right. Yeah, yeah,
Same
yeah.
do in MATLAB.
Yeah, yeah, yeah. Yeah,
I used to teach.
yeah. Okay. Yeah, yeah. Yeah. So now you don't deliver any course on safety.
Currently,
Yeah.
most code I'm on the course. So this
No, sure. Yeah, but to say that is also a good thing to use for teaching, isn't it? Because you can get them started and yeah.
so there was a talk we were planning together. Only thing is my course load changed. So I was now taking different course.
Okay.
I can feed all the code.
Oh, no, no, no. No, no, for sure. What do you teach now? Is it?
Process engineering and
Okay.
process safety.
Okay, 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 okay.
The next semester, we have a industrial course, natural gas engineering.
Okay, sure. Yeah, 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 yeah.
From Gas Authority of India Limited. They are from the natural gas sector.
Sure.
So they come.
Ah, right, it's like an industrial, yeah, industrial, you mean deliver to industry. Yeah.
from the
Right.
industry. Just to people who
Ah, okay, right, so you run it with a lot of,
research more than
to the industry.
But we have to go with the documents.
sites.
What we have already.
Yeah, no, that's good. So how big, your year, in a year, how many students do you have? Like your, it's a chemical engineering degree. So how many students per year do you get? Do you,
In our university,
yeah,
in our university, it's around 20, 24, 25.
Okay.
Translating to third class.
yeah. Okay. So that's what I was thinking. It's, this industrial is nice. Sometimes if you have big numbers, it might be difficult to arrange the visits and everything, but I think if you have a student population of, I don't know, 25, 30 students, or is it? Oh, I see. Okay. So you get,
Industry, everybody is required for that. So you want to explore schooling system.
Yeah.
Aspects of industry.
yeah.
5.5 4
Natural gas industry, when you are running long time.
different measures.
Yeah.
And
Okay.
you will
Documents around load.
So it's a course not just for the chemical engineers, but for the whole, yeah.
measure everything that is mechanical.
Careful, man. And
So how many students do you collect in in that course?
Okay, target.
and
13 students are.
documents load over. Documents.
Yes, so that's a good idea though. I think it's very good idea if you can do this visit. It's because a lot of departments don't do it these days. It's very difficult to arrange that. Yeah, that's yeah.
That's the
Yeah.
yes.
Yeah.
So we take
Yeah.
the site, explain everything, show them which is how big it looks.
Exactly. Yeah, it's not like just that. Yeah. No, it's
So they get for the first time like okay.
Momentum trans-
yeah.
And that
The
is
first time. And then, but that's good. Yeah. Should let you do your grid now. Do you know how to make a cylindrical geometry? Let's see. Good luck. I'm not you. Yeah. Come on, you need to progress.
Momentum transport equation.
Let's open that first. Sorry.
ब्लॉक में चलिए उसके बाद इनको हम
So how are you doing then? You look stressed. Yeah, no, yeah, that's right. Have you done any safety before?
council.
Council, yeah.
11
It's a big difference. Okay, it's not. Good luck. Yeah.
हाँ आप जाते टाइम वो ले जाना बाकी हम
How are you doing then? Yeah, still struggling? That's still the beginning though. It's okay. Yeah. Have you done any safety yourselves in the past? Or, yeah. Yeah. Right. Yeah.
INT
Okay. That's yeah, Basilisk. How much more user friendly is Basilisk? How much more user friendly is Basilisk if you want to?
I use I think that for any business I can do some simulation, some simple simulation I can do.
Yeah, okay, firstly, because you just beginning here. Simply, you mean what, like simplified flow or?
Casting one,
Okay,
rising one inside the
yeah, so two phase in a way, but yeah,
making as well as the busting ones inside the simulation.
okay.
I also can do the deeps which are the affect structure on the plane.
On the, yeah. Okay, that's quite advanced. Yeah. So, but maybe simpler geometries then, is it? Yeah. Yeah.
Currently actually I have a problem that we solve that problem because it's my current problem.
Really? So because you cannot capture the physics, or what do you mean you have a problem?
The problem is that because the discuss because we have to solve the separate discovery. This is not a full experiment.
That's right. Yes.
Is used for the full year.
Right.
Also,
Ah,
the interface.
yeah.
For second we have directly control the OFL.
Yeah. Yeah.
Does understand the purpose.
And
Yeah. Okay. Okay.
I think that's why we say we are under the load.
To-
We have
Just focus. Fatal error already. Yeah. It's okay. Yeah. Yeah. Right. So you have not done any coding at all. No. Okay. Okay. It's good to get the exposure, isn't it? Because if there is a need. So your experiments are on what? Oh, sorry.
लोग में
Mini chat. Sorry.
तो 12 ये दो
What do you do?
आ रहा है समझ तो मैं समझ गया वो तो स्टूडेंट वगैरह मेरे सिस्टम पड़ा है वो मेरे में आवे वो तो
Okay. Oh, for the wetting properties. Yeah.
चल
Yeah.
रहा है
So that would be your PhD project, or yeah. So droplet formation and yeah. Right.
यानी कि हमें
Do you have any sort of applications,
वो 11
or is it just more generally the fundamentals?
11 पे बना के लाया था वैसा है कि ये वाली मोमेंटम का
No, but they're there, yeah. Where do you come from? Which university?
कोई नहीं तो सही कर सकते तुम्हें तो पता है ज्योमेट्री बनाना सिखाना
Okay, that's allowed. That's good, though. That's a very okay. Oh no, physics. So physics, and now you are starting the. So are you working with Professor Ghosh then, or what? Okay, okay. Macrophysics, yeah, okay, yeah.
इसी में ओपन टर्मिनल इधर इसमें पाइप जीरो में जाओ हाँ
I see. Okay, how long have you started? When did you start?
हाँ ब्लॉक में
Okay, so you're just doing the reading at the moment, yeah. But actually, maybe it is an idea because you can do some simulations of the droplet formation. Maybe, okay, if you're mainly experiments, you're mainly experiments. But, I mean, I've also showed as well that you can actually do some simple simulations. So it might be, you get something to use. Yeah. One thing at a time, done. But yeah, good luck. Good luck with this first. Yeah. Yeah. Right, how are things here? How is it going? Yeah. Yeah. Have you done any simulations before? No. Okay. Okay. Yeah. So you're doing experimental work, what do you do? Yeah. What sort of systems? What are you investigating? Yeah. Oh wow. Okay. So this is but do you do it in small channels, or how do you do it? Yeah. Okay. Okay. Are you here? Are you in IIT Roorkee here? Okay. Yeah. Yeah. Right. So it can be a bit challenging to get started, isn't it? So, yeah. I mean, just follow the instructions, and the guys are here to help. So yeah. Hi. Don't ask me questions. They know better. So how are you doing?
I'm not getting how to proceed with that.
Hmm?
How to proceed?
How to proceed? Um, how to proceed? I don't know. I don't know what your instructions are. If somebody went a step ahead, what is he doing now?
What problem? So this is a general content base. So we have provided to all the PDF file. Okay. So in any working phase, we have provided three folders, three cases, and each case is in the best size. So in each of component, there are the types of basic folder. Zeros, constant, and system. Now, before we are going to use zero folder, the folder which contain all types of boundary condition. Which you have to define boundary condition. But before defining boundary condition, you have to change mesh. So mesh one folder has three. It's a renewable stationary, it's in the block mesh stationary. This is an in the block mesh stationary. Okay, so this is the general format. So in the very first line, you have we have written the local global. if you write it one, what usually it means that you are basically dealing in meters. Since we have given a scale of 0.001, that means we are working in millimeters. Now, what actually happens in block math is how generally create hexagonal scale. For example, you have this small big unit. You have any
Actually, we work on the one page or two page within the calculator.
unit shape of hexagonal shape, not any particular triangles. You cannot have tetrahedron in block notation. For that, if you want to tetrahedron,
We have already set up
create a
like
geometry to create an STL file, import it over here. But that's another case. But since it is a simple case, it's been working in block math dictionary. So, these are the various vertices that will be used for the creation of the geometry. Now, as I told you that we will work on the head of this. Now we have to, once we created means what this is a network, we have created using block strategies. We can show the art of step by step. How do we run? Since it is inbuilt stock, so just write block.
this is our you have to custom. We are just the instructions. Yeah,
This is done.
there is no
You
both
want
are
to
both
how your geometry has this one. You want to write
run the simulations after testing everything.
create a dummy point.
Go on the terminal, then
And the
load the
path
block man, whatever solver you are using. But you have to load the open box which you are working on. Then you load the block man, both process in the solver. Okay. Yeah, there is, we have done everything here. Now you want to look for the instructions. But for the simulation, there is only one page simulation. Only water is flowing inside the capillary. Okay. But in that case, we have explained the two page also. Like for tomorrow, we will discuss about the two page and the
Get
capillary,
there,
where you have the contact angle.
so only half an hour, but you have hours.
Only one fluid.
So the
And tomorrow we will work on the two fluids. And obviously, second fluid is here already inside the capillary before
Yeah.
inserting the liquid. But in the tomorrow we will learn when we will insert the two liquids at the inlet. Then they will be dispersed inside the capillary. And we will see how they are interacting and what type of the droplet are forming, what type of the slug length, what is the film thickness around the slug. So for right now, we are just working on the one page inside a capillary, that is a 3D capillary, and the fluid is flowing inside that. And when you will flow two fluid inside the capillary, and there will be the interaction at the inlet. And due to this interaction, like when you will change the surface tension or the viscosity or everything, then by changing all the thermophysical property and the variability of the wall, there will be a different interaction between the fluids. Okay. Like one time I am flowing oil, and second time I am flowing the water. The third time I am flowing some organic liquid like the oil. So there will be different interaction every time. But today we are flowing only one fluid. On the Paraform, you will have the after running the simulation, Paraform, paraviewform.com. Yes. Yeah. It's on this. So right now we don't have any simulation, so you will see nothing. After the running the simulation, you can see everything on the Paraview. To not find the valid open form match. Actually, we haven't load the block match. Okay, so now you can visualize. You can change the axis, that is the front, back, everything. You can cut also, like that's not access. Oh, yes. And then see the surface with edges, how the matching is going on. So this is the matching. Yeah, matching in the block match. Yeah, I will. Yeah, that this is the front. That liquid is going from here, and the other part is outlet. This is the inlet.
Create a fold, create an empty fold. How create an empty fold? Before doing the two,
हाँ, ठीक है. Actually, there is form.com, one dummy file. By using this will read only particular simulation. Like we have three files like 50, 51, 52, but when you will create form.com for the 50, and when you will select form.com from the 50 to the paraview, then they will create the simulation of 50 only. So that is a dummy file for that.
like how to create a, for example, if I have to create a fold, so you determine how to do this.
How to?
So to create a fold, how to create an empty folder by what is this mean?
Just type that command, touch form.com, then it will create a form.com. We have already created, then it will show. You can delete that form.com, then again create. One by one, point by point. First delete form.com and cut this simulation, then load the block map directly by going on the.
Okay.
Yeah. It will-
What
You have already. ये 4 बजे आ जाना. क्या? अच्छा. ठीक. भैया 4 बजे केमिकल में भेज देना गाड़ी. आओ. बोलना है, थोड़ा सा बोलना पड़ेगा. ठीक है, मैं बोल देता हूँ थोड़ा सा, है ना. तो ये ऑन है माइक, इधर कर लेना फोकस. करूँ स्टार्ट? Good afternoon, everyone. So today we are performing the tutorial 4, and in tutorial 4 we will learn about the basics of the open form, and we will perform the simulation by using the two-phase flow in the capillary 3D capillary. So here we have already installed the open form 11 in all your desktops, and we have one PPT. You can see from that, like we have written all the steps you have to follow, and we will do it in 4 steps. First we have to install the software, which we have already did, And in the second step, we will do the pre-processing. In the pre-processing, you have to learn about how to form the geometry and how we can change the matching of the geometry for the different kind of the simulations. In the second step, we will see the processing. In the processing, we will learn about how we have to give the boundary conditions for the pipe wall, and how we have to find out the interface between the two fluids. And in the last, after performing the simulation, we have to see how we have to visualize the results in the ParaView software. So here we have three directory like zero, constant, and system, and I have written everything about like what we have in the zero. Like in the zero directory, we have to give the boundary conditions, and in the constant directory, we have to give the physical properties of all the fluids we are using. And in the system directory, we have to create the geometry, like we are creating the geometry here in the block mesh, and how we have to discretize that geometry, how to refine the geometry. We have to do this in the block mesh, and it will be did in the system directory. And when you will open the zero folder, then you have to find like we have three different directory. One is phase fraction directory, where we have to give the fractions, like if we are using the two different fluids, or one is air or whatever, we have to give the phase fraction for that. Like in that kind of simulation, we are using one for the water and zero for the air. Actually, right now, today we will perform only simulation by using the one fluid only. So air is already in the walls. Sorry, air is already in the tube. So we are injecting the water from the inlet. So here we have initialized the air by the zero and the water by the one. And in the second directive, we have to give the pressure boundary condition, and in the third one, we have to give the what velocity we are performing the simulations. And in the second, you can see like we have to give the values of the gravity value and the physical property of the liquids and the air. And in the third one, we you can see there's a directive of the turbulence properties. If the simulation is turbulent, then only you have to write the turbulence. Otherwise, like we are using the laminar, then after opening that, you have to write the laminar. So in the system folder, you can see we have block mesh and control dict. In the block mesh, we are generating the geometry and the meshing. And in case of the control dict, we are giving the step size of the saving the simulation results, and we can give the time in the control dict. And one is decompose per dict. If we have different core system, then you can decompose the simulation, then it will be run parallel. Like if you have 100 cores, then you can decompose into 100 core, and the simulation will be run parallel in the 100. And third one, okay, these are okay. So now you can see we have attached one photo of that block mesh. So you can see how we are giving the scaling and the vertices of the geometry, and what is the length, how we are giving the length and everything. So after specifying all these properties, so you have to open the terminal. After opening the terminal, you have to load the mesh by typing the block mesh. After loading the block mesh, for running the simulation, if the simulation is running on one core, then you have to type the interform. But in case if you have decomposed the you have used the decompose per dict, then you have to use MPI run minus MP interform minus parallel. So all the simulation will be run in the parallel. ठीक है भैया, thank you.